Hello viewers, greetings to you and welcome to my channel. Here I teach people how to design, install and maintain solar power systems. Now, it is all about determination. Once you are determined that I want to know this thing, this is the skill I want to learn in 2024 to add to my profile, it is very, very possible. It all starts from having a determined heart, being courageous, being bold enough to take a concrete decision that this is what I want to do with my life. Once you are able to take that decision and you are determined to achieve that your set goal, it is always possible to achieve whatever you want to achieve in life. Now, for a start, because I like starting from the scratch, there's what we call components of a solar power system. That is what I'll be treating today. Components of a solar power system. Just like we have our generator, there are different parts, that makes up the generator, the fuel tank, the carburetor, the plug. There are different parts. So all these parts are combined together to make the generator to generate electricity that is being used in household or used domestically or commercially. No, now for a solar power system, there are also components that makes up a solar power system. Now, if you are a solar installer or you want to be a solar installer, you should be able to know how to combine all these components so that they will be able to convert the sun's energy into electrical energy. If you are not able to properly size these components and combine them together after installation, the system will be having issues. At times, the system will fail completely and you'll be having issues with your clients because the solar components are expensive. So after your client might have spent a lot of money, at times millions or thousands, to install the system and is not giving the person the desired result, the person will not be happy. So it all starts from the scratch, building the system from the scratch, knowing how to combine these components. So I'm going to explain these components to you using a block diagram. I call it the block diagram of a solar block diagram showing the components of a solar power system. So the first component that we have is the solar panel. We have the solar panel here. This is our solar panel. Now, the solar panel is the generator in a solar power system. So long as you call that system a solar system, a solar power system, what generates the energy is the solar panel. The solar panel converts the sun's energy into electrical energy. Now, this is a solar panel. The solar panel is made up of cells. This panel here is a 72 cell a monocrystalline solar panel. Now, when you connect cells together, it will form what we call solar panel. So this is a complete solar panel. When you expose this solar panel to the sun, the cell starts generating energy. And this energy is generated in the form of DC, that is direct current. Now, for the solar panels, we have the monocrystalline solar panel, we have the polycrystalline solar panel, and the amorphous solar panel. So the ones that are commonly used are the monocrystalline and the polycrystalline solar panel. In the course of this training, I will show you practically, there's what we call the nameplate or specification sheets that is being all panels have their specifications. They are always rated in watts. And at the back of the panel, there are things you see there. You see the open circuit voltage, you see the short circuit current, the maximum power current, and the maximum power voltage. Now, these parameters will help in guiding you on the choice or how to size your charge controller. So from the solar panel, when the solar panels harness the energy, generates this energy in form of DC, the energy passes through a device, another component, passes through another component called the solar charge controller. The short form is SCC, solar charge controller. Now, the solar charge controller controls the charging and discharging of the battery. It is unprofessional. It is a very bad practice for you to connect the solar panels directly to the battery. It will kill the cells of the battery. The cells of the batteries will die very, very fast. So in every solar installation, there is always a solar charge controller. You must install a solar charge controller so that it will be able to control the charging of your battery. Now, for the solar charge controller, we have the MPPT charge controller, that is maximum power point tracking. Then we have the PWM charge controller, pulse width modulation. Now, these are the two types of solar charge controllers that we have in the market. The MPPT charge controller performs far better than the PWM charge controller. Now, from the charge controller, this energy, still DC, moves to the battery. This is our battery here. Moves to the battery. The battery is like a reservoir. It is a storage tank. When the panels generate the energy, we know that the sun is only available during the day. Now in the night, there's no sun. So when the solar panels generate, they store this energy in this tank, in this reservoir called the battery, so that when the sun is no longer available, the battery will, deliver the energy that has been stored. Now, here we have DC. Here is also DC. So the solar panels generate the energy, sends the energy to the battery through the charge controller. The energy is being stored here. Now, for the batteries, we have the lithium batteries, we have the flooded battery or the tubular battery, we have also the sealed batteries. These are the different types of batteries that we have in the market. The lithium battery is the latest technology that most installers are using. It is a good battery for some manufacturers. You can discharge it up to 100% DOD. In the course of the training, I will explain all these things to you. There are differences, how to know the energy that is stored in that battery, their voltage system, how to connect them in series or in parallel. Like the panels, you can connect them in series or in parallel. Likewise, the batteries, you can also connect them in series or in parallel. Now, this from the charge controller here, you can also power what we call DC loads from this charge controller, directly from the charge controller. You can power DC loads. Sorry. Remember, we have AC loads and DC loads. AC is alternating current. DC is direct current. Most of our conventional appliances here in Nigeria are AC appliances. Our bulbs, our refrigerators, our television, a lot of appliances that we use are AC appliances. But we still have DC appliances, like what we call the solar pump. The solar pump is a DC pump. We still have solar freezer. All those appliances are DC appliances. You can connect them directly from here, but all of them have a reference voltage, either 12 volt or 24 volt. So you need to know the voltage of that appliance, whether the DC appliance is a 12 volt appliance, a 6 volt appliance, is a 24 volt or a 48 volt appliance. That is where you know whether it will be compatible with the charge controller you have, because the charge controllers are also rated in both voltage and in amps. We have some that are automatic. They have 12 volts, 24 volts, 36 volts, and 48 volts. Some are only 12 volts. Some are only 12 and 24 volts. So you need to know if your loads, the loads that you want, the DC loads that you want to power from the charge controller, will be compatible with the charge controllers. Now, from the battery, there is another component again. We call it the inverter. From the battery, we have our inverter here. This is the inverter. Now, here is the DC side of the inverter, and here is the AC side of the inverter. Now, what is the function of the inverter? We know that the energy that is generated by the solar panels is DC, direct current. The one that is stored in the battery is DC, also direct current. Now, our conventional appliances, the appliances we are using, they are all AC appliances. Now, how can we use these appliances when we are having the energy that is stored in the battery is DC? That is where the inverter now comes in. The inverter converts the DC that is stored in the battery to AC. That is the function of the inverter. So once you impute your DC power, it will convert to AC, so that it will be able to power your AC loads. Now, the inverters are also, they have their own reference voltage also. We have 12 volts inverters, we have 24 volts inverters, we have 48 volts inverters. We have different, we have inverters with different voltage. So you need to know the voltage of your inverter before you connect it to the batteries. Now, if it is a 12 volt inverter, you can connect it directly to a single 12 volt battery, because it is a 12 volt inverter. But if it is a 24 volt inverter, you cannot connect it directly to a single 12 volt battery. What you need to do is that you need to connect these batteries in series to give you 24 volts, so that you'll be able to power the 24 volts inverter. So for the inverters, we have the modified sine wave inverter and the pure sine wave inverter. The pure sine wave, their power output is pure, just like the power from the grid or from the generator. But the modified sine wave, the power output is not pure as compared to the pure sine wave inverter. And they are sensitive electronics, they are sensitive electrical appliances that the modified sine wave inverter will not be able to power. If you plug them to a modified sine wave inverter, those appliances may get bad, because they are not, they are the communication or the relationship is not smooth. Why? Because the power output is not pure. So these are the components of a solar power system. Now, in this diagram, you must introduce what we call breakers. There must be breakers between the solar panel and the charge controller. You need to install a breaker, a DC breaker. A DC breaker must be here. Between the solar charge controller and the battery, you also need to install a DC breaker because what is passing through here is DC. Now, even the load, if you have a DC load, you also need to install a breaker. Then from the battery to the inverter, you also need to install a DC breaker. Although some inverters, most of the modern inverters, they have their inbuilt DC breakers. Now, from the inverter, we have our loads. From here, you can power your AC loads. Now, you also need a breaker here, an AC breaker. Some inverters also come with the AC breaker, so you will not need to install another breaker. Then there are other components like the surge protective devices, the thunder arrestors. All these are meant to protect the system so that in case of a lightning strike, in case of anything like short circuit, the system should be able to shut down on its own without affecting these components. So that is why there's need for you to install these breakers. Now, what links all these components together is cables. You also need to know how you know how to properly size the cables that will come from the panels to the charge controller, from the charge controller to the battery, from the battery down to the inverter, also from the charge controller to your loads. You need to know how to properly size the cables. If you use undersized cables, the system may heat up, and before you know it, the inverter will be beeping. It will be tripping off because those cables are not, they are not strong enough. They are not good enough to, sustain the inverter. Then from the solar panels to the charge controller down to the battery, if the panels are connected in parallel, it means you're building up the voltage. So you should be mindful of the size of cables you are using because the current that is coming out from the panels down to the batteries is high. So if you use undersized cables, at the point those cables will get burned. So as a solar installer, you need to know how to size all those components. Now, in the course of this training, I'm going to show you how to size the solar panels, how to size the charge controller, size the battery, and the inverter, then also how to size these breakers, also how to size the cables, how to also carry out an energy audit. That is, if you have a client is interested in your services and tells you, oh, I want to install a solar system in my house. Solar system is not dependent on how many rooms the person is having. It is dependent on the appliances that the person is using, the power rating of the appliances. So once you know the power rating of the appliances, during load audit, you check all the appliances that the person want to use on solar. Then you now calculate the power. From the power, you now calculate the total daily energy consumption that the client will be using. It is from those parameters, the total power and the total daily energy consumption, that you use to size all these components. So do well to if you enjoy the teaching, I plead that you like the video, you can share, you can comment, just to show that you enjoyed the teaching. Thank you, and see you in my next video. In my next class, I'll be available to take us on another topic. Thank you very much for watching. You have a nice and wonderful day. God bless you.